Hi dear students, welcome back to online classes. I am your Guru. Today we are going to discuss about Dalton atomic theory. This theory was proposed by Dalton. It was proposed by Dalton. Now let us discuss the postulates of Dalton atomic theory one by one. The first postulate: elements are made up of tiny particles. Tiny particles are called as atoms. Elements are made up of tiny particles. Tiny particles means small particles. These small particles are called as atoms. According to Dalton atomic theory, the second postulate, atoms can take part in chemical reactions. Take part in chemical reactions. Means atoms they participate in chemical reactions. The third postulate, atoms cannot be created or cannot be destroyed during the chemical reactions. Atoms cannot be created or destroyed. This is the third postulate of Dalton atomic theory. Next, the fourth postulate. Atoms of same elements are identical in size, mass and other properties. The fourth postulate is atoms of same element are identical in size and mass and other properties. For example, if you consider hydrogen element, all atoms in hydrogen are identical in size, mass and other properties. Fifth one, atoms of different element are different in size, mass and other properties. For example, if you consider two elements, one is hydrogen, the another one is oxygen. Hydrogen atoms and oxygen atoms are not identical in size, mass and other properties. Why? Because they are different in nature. Their atoms are different elements. They are obtained from different elements. So atoms of different elements are different in size, mass and other properties. The sixth postulate, atoms of different elements combine in simple whole number ratio. Simple whole number ratio to form compounds. To form compounds. These are the postulates of Dalton atomic theory. The first postulate is elements are made up of tiny particles. Tiny particles means small particles. These particles are named as atoms. The second postulate, atoms can take in chemical reactions. Mean atoms, they participate in chemical reactions. The third postulate, atoms cannot be created or cannot be destroyed during the chemical reactions. The fourth postulate, atoms of same element are identical in size, mass and other properties. For example, all atoms of hydrogens are identical in size, mass. Next, fifth postulate, atoms of different element are different in size, mass and other properties. Atoms, for example, hydrogen atom and oxygen atoms are different in size, mass and other properties. The last sixth one, atoms of different element combine in simple whole number ratio to form compounds. Example, say hydrogen, it combines with oxygen and it gives water molecule. Combine with oxygen and it gives water molecule. The atoms of different elements, they combine in simple whole number ratio to form compound. Here the ratio is 2:1. Means 2 hydrogens and 1 oxygen. These are the postulates of Dalton atomic theory. Limitations of Dalton atomic theory. Dalton theory could not explain structure of atom. It could not explain structure of atom. Structure of atom. This is the first limitation of Dalton atomic theory. The second one, it could not explain nature of forces between atoms. Yes, according to sixth postulates, atoms of different elements combine in simple whole number ratio to form compound, but it could not explain nature of forces between atoms in compound. It could not explain nature of forces. Nature of forces between them. This is the second limitation of Dalton atomic theory. The third one, according to sixth postulate, atoms of different elements combine in simple whole number ratio to form compounds, but it could not explain why atoms of different elements are combining. It could not explain why atoms of different elements, atoms of different elements combine to form molecule. Combine to form molecule. These are the limitations of Dalton atomic theory. Atomic mass. Actually, it is the relative atomic mass, but simply we call it as the atomic mass. It is a relative atomic mass. Relative atomic mass. Why? Because atomic masses are calculated with respect to some standard element, because mass of atoms are very small in number, so they measure or they calculate with some standard element. The atomic masses are measured or calculated with the help of mass spectroscopy. Mass spectroscopy. This is the instrument. It is used to determine atomic mass accurately. Okay. And the atomic masses are very small in number. That's why all atomic masses are calculated with respect to some standard element. The standard element is standard element, that is carbon 12 isotope. Carbon 12 isotope. With respect to carbon 12 isotope, all atomic masses are calculated. Then, what is atomic mass? Atomic mass, it is a mass. It is mass of one atom. It is mass of one atom of element. One atom of element with respect to 1 by 12th mass of 1 by 12th mass of one atom of carbon 12, one atom of carbon 12 isotope. This is the definition for atomic mass or relative atomic mass. Why? Because why it is relative atomic mass? Because the atomic masses are calculated with respect to some standard element. The standard element is carbon 12 isotope. Why they are using standard element? Because when the atomic masses are measured with the help of mass spectroscopy, the mass of atom is very small in number. That's why they are using standard element. And what is atomic mass? It is mass of one atom of element. It is a mass of atom. It is a mass of atom with respect to 1 by 12th mass of one atom of carbon 12 isotope. The carbon 12 isotope is standard element. In the exam, they will ask for one mark. What is the standard element during the calculation of atomic masses? The standard element is the carbon 12 isotope. And the atomic masses are we express in atomic mass unit. It is a unit. Atomic mass unit. Atomic mass unit. AMU. The atomic masses are expressed in atomic mass unit because the mass of atoms are very small in number. Atomic mass unit is defined as the mass exactly equal to the mass exactly equal to 1 by 12th mass of 1 by 12th mass of one atom of carbon 12 isotope. Carbon 12 isotope. It is very important for one mark. They will ask what is atomic mass unit. Atomic mass unit is defined as the mass which is exactly equal to 1 by 12th mass of one atom of carbon 12 isotope. For example, consider a carbon 12 isotope. This is a carbon 12 isotope. Now you divide it into 12 parts. Divide it into 12 parts. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, and 12. You take one portion. This is 1 by 12th. This is 1 by 12th portion of carbon 12 isotope. The AMU, atomic mass unit. Atomic mass unit is equal to, exactly it is equal to mass of 1 by 12th portion of carbon 12 isotope. 1 AMU is equal to 1 by 12th mass of one atom of carbon 12 isotope. One atom of carbon 12 isotope. 1 AMU is equal to 1 by Avogadro numbers. Avogadro number is constant. It is a constant value. 1 by Avogadro number is 6.022 into 10 power 23. This is Avogadro number, constant number. Okay. 1 AMU is equal to 1.66 into 10 power minus 27 kg. 1 AMU is equal to 1.66 into 10 power minus 24 grams. In grams, 1 AMU means 1.66 into 10 power minus 24 grams. In kg, 1 AMU is equal to 1.66 into 10 power minus 27. It is also very important for 1 mark. In exam, they will ask, write the value of 1 AMU. In grams, the 1 AMU value is 1.66 into 10 power minus 24. In kg, it is equal to 1.66 into 10 power minus 27. These values are constant values. You remember these values. Generally, mass we measure in kilograms, grams. 1 kg is equal to how many grams? 1000 grams, like that. 1 AMU, it is a unit. It is used to measure mass of atom. 1 AMU is equal to 1.66 into 10 power minus 24 grams. Okay. Atomic mass unit. Atomic mass unit is also called as unified mass. Unified mass. That is denoted by capital U. Atomic mass unit also called as unified mass. Nowadays, instead of AMU, we use capital U. Okay. Now let us take one example. With the help of mass spectroscopy, we can calculate or we can determine mass of atom. With the help of mass spectroscopy, we got mass of hydrogen. Mass of hydrogen atom is 1.6736 into 10 power minus 24 gram. This is the mass of hydrogen atom. Now, what is the 1 AMU value in grams? 1 AMU value in grams is 1.66 into 10 power minus 24 gram. Now you convert the mass of hydrogen atom in AMU, because the mass of atoms will be expressed in atomic mass unit. Why? Because these numbers are very small. They are very small numbers. It is very difficult in calculation. So we are converting grams into AMU. Okay, now let us convert mass of hydrogen atom. Mass of hydrogen atom in AMU. In AMU, atomic mass unit is equal to the mass of hydrogen atom in grams, 1.673 into 10 power minus 24 gram. Then what is 1 AMU value in grams? 1.66 into 10 power minus 24 grams. If you divide these numbers, you will get nearly 1.0078 AMU. We'll get 1.0078 AMU. If you round up this number, you will get 1.008 AMU. The atomic mass of hydrogen in AMU. Yes, the last number is 8. It is greater than 5. So remove the last number and add 1 to preceding number. That's why 1.008. The mass of hydrogen atom in AMU is 1.008 AMU. This is very simple to calculate. This calculation of this number is simple compared to this number. The next one, gram atomic mass. gram atomic mass. Gram atomic mass is mass of 1 gram atom. It is mass of 1 gram atom. 1 gram atom is called gram atomic mass. It is the mass of 1 gram atom is called gram atomic mass. Or we can say that it is mass of 1 molecule atom, 1 mole atom or 1 molecule atoms. It is mass of 1 mole atom or it is a mass of 1 gram atom. Gram atomic mass is numerically it is equal to atomic mass. The gram atomic masses values are numerically equal to atomic mass values. Now let us take one example. What is the atomic mass of hydrogen atom? What is the mass of hydrogen? Atomic mass of hydrogen atom is equal to 1.008 AMU. This is the atomic mass of hydrogen atom. Now gram atomic mass. What is the gram atomic mass of hydrogen atom? The gram atomic mass of hydrogen atom is numerically same as atomic mass of hydrogen atom. It is also 1.008, but the unit is different. Here we have to write grams per mole. Right? The numerical values are same. Atomic mass and gram atomic mass, the numerical values are same, but the units are different. The gram atomic mass unit is gram per mole. The atomic mass, its unit is AMU. Okay, this is gram atomic mass. Now let us go for average atomic mass. Average atomic mass. Average atomic mass means average mass of different isotopes of elements. For example, carbon. It exists in 3 isotopes: carbon 12, carbon 13 and carbon 14. The average mass of different isotopes of element is called average atomic mass. It is weighted average. It is weighted average of different isotopes of elements. It is the average mass of different isotopes of element. For example, carbon, it exists in 3 isotopes: carbon 12, carbon 13, carbon 14. What is the atomic number of carbon? 6. Here, what are isotopes? Isotopes means atomic number is same, but mass number is different. The atomic mass is different. For such cases, we calculate average atomic masses. If element exists in isotopes, then we use average atomic mass. Average atomic mass formula is average atomic mass is equal to x into A plus y into B plus z into C, etc. divided by 100. This is the formula to calculate average atomic mass. If only 2 isotopes are present, only two isotopes are available, then we use this formula. x into a plus y into b divided by 100. If percentage of x, if percentage of x is known, if percentage of x is known, then y is equal to 100 minus x. Then the average atomic mass formula is, the average atomic mass formula is x into a plus 100 minus x into b divided by 100. This is the formula to calculate average atomic mass. Then what are x and what are a? See, where x, y, z are percentage abundance of isotopes, means percentage of isotopes. X, y, z are percentage of isotopes. Then what about A, B, C? A, B, C are atomic masses of isotopes. Atomic mass of isotopes. Now let us solve some numerical based on this formula. This is the numerical, first numerical. Calculate the average atomic mass of carbon from the following data. Carbon, it exists in 3 isotopes, carbon 12, carbon 13 and carbon 14. There the percentage abundance, carbon 12 our percentage abundance is 98.892. The percentage of carbon 13 is 1.108. The percentage of carbon 14 is 2 into 10 power minus 10. And atomic masses, carbon 12, its carbon 12 atomic mass is 12, carbon 13, carbon 14, atomic mass is 14.00317. Now we have to calculate average atomic mass. Now let us calculate average atomic mass. The average atomic mass is equal to, we know that formula, x into a plus y into b plus z into c divided by 100. Because there are 3 isotopes, I am using x, y, z. Now x, y and z are percentage abundance. A, B, C are atomic masses of isotopes. Now let us substitute the values. X means 98.892 into, what is A? 12 plus, what is Y? What is the percentage abundance of second one? 1.108 into B. B means atomic mass of carbon 13. Atomic mass is 13.00335. Okay. Next, Z plus Z. Z means percentage abundance of carbon 14. 2 into 10 power minus 10 plus, into, what is C? C means atomic mass of carbon 14. 14.00317 whole divided by 100. Now you simplify this one calculation. After simplify this calculation, we will get 12.011 U. This is the average atomic mass of carbon. The average atomic mass of chlorine. Here we have to calculate average atomic mass of chlorine by using given data. Here chlorine, it exists in 2 isotopes. One is chlorine 35, another one is chlorine 37. The percentage abundance. The percentage of chlorine 35 is 75.77 and the percentage abundance of chlorine 37 is 24.23. And atomic masses. The atomic mass of chlorine 35 is 34.9689 the atomic mass of chlorine 37 is 36.9659. Now let us calculate average atomic mass. Average atomic mass. Average atomic mass. Here there are only two isotopes are there. So the formula is x into A plus y into B divided by 100. What is x? X means the percentage abundance of first isotope. The percentage is 75.77 into what is A? A means atomic mass. The atomic mass is 34.9689 plus what is Y? Percentage abundance of second isotope 24.23 into what is B? B is the atomic mass of second isotope 36.9659 divided by 100. Now simplify this one. Simplify this. After simplifying this one, you will get 35.45. After this one, you will get 35.45 to U. These are the numericals based on the average atomic mass. This is homework. Please solve this one. Okay. Here the carbon obtained in nature as carbon 12, carbon 13 isotopes. Here only there are two isotopes are given. And the carbon average mass. Here average atomic mass of carbon is 12.011 unified mass. U means unified mass. Calculate percentage abundance of each isotope. Okay. Thank you. In next class we will continue.